Hi everyone, welcome to today's session on permutations and combinations. By the end of this video, you understand what these concepts mean and how to apply them in solving problems. Let's get started! Before we begin, I would like to introduce myself. I am Rian Birsario, a grade 10 Diamond learner. For our today's agenda, permutations and combinations, where we understand the basics of counting principles. Introduction. Permutation and combination are fundamental concepts in mathematics and statistics. Permutation, arrangement of items where the order matters. Combination, selection of items where the order does not matter. Let's start in permutations. Permutation is the arrangement of items in which order matters. Note, order matters. Example, imagine you have three letters A, B, and C. How many different ways can you arrange them? The answer is ABC, ACB, BAC, BCA, CAB, and CBA. In total, there are 6 arrangements. But how do we calculate this without listing all the possibilities? That's where the factorial comes in. The formula for permutation is P equals n factorial over n minus r factorial, where n is the total number of items, r is the number of items you are arranging. Let's calculate the given example earlier. Process. Formula for permutations. The general formula for permutation is P and r equals n factorial over n minus r factorial. Substitute the values. P3 equals 3 factorial over 3 minus 3 factorial. Simplify factorials. 3 factorial equals 3 times 2 times 1 equals 6. 3 minus 3 factorials equals 0 factorial equals 1 by definition. P3 equals 6 over 1 equals 6. The answer is 6. That's it for permutations. Now let's go to combinations. What is combinations? A combination is an arrangement of items in which order does not matter. Note, order does not matter. Example, if you have the same letters A, B, and C, how many ways can you select 2 of them? The answer is AB, AC, and BC. Here, there are only 3 combinations because the order doesn't matter. AB is the same as BA. The general formula for combinations is C and R equals n factorial over r factorial n minus r factorial. Let's now calculate the given example earlier by applying the general formula for combinations. Process. The general formula for combinations is C and R equals n factorial over r factorial n minus r factorial. Substitute the values. C3 equals 3 factorial over 2 factorial, 3 minus 2 factorial. Simplify factorials. 3 factorials equals 3 times 2 times 1 equals 6. 2 factorial equals 2 times 1 equals 2. 3 minus 2 factorials equals 1 factorial equals 1. Substituting these values, C3 equals C over 2 times 1 equals C over 2 equals 3. The answer is 3. And that's it for combinations. Now let's go to key difference. To summarize, permutations are for arrangement where order matters. Combinations are for selections where order doesn't matter. These are the real-life applications. Permutations are used in seating arrangements, password generation, or arranging books on a shelf. Combinations are used in choosing teams, lottery numbers, or forming committees. Let's now have another practice problem. In permutations, how many ways can 5 students line up in a row? The first step to solve the problem is substitute the values into the formula. P 5 equals 5 factorial over 5 minus 5. Simplify the factorials. 5 factorials equals 5 times 4 times 3 times 2 times 1 equals 120. 0 factorials equals 1 by definition. P55 equals 120 over 1 equals 120. The answer: there are 120 ways to arrange 5 students in a line. Let's now have the problem in combinations. How many ways can you select 2 students from the 5 to represent a team? Let's now dive into solving the problem in combinations. Substitute the values in the formula. C 5 2 equals 5 factorial over 2 factorial 5 minus 2 factorial. Simplify the factorials. 5 factorials equals 5 times 4 times 3 times 2 times 1 equals 120. 2 factorials equals 2 times 1 equals 2. 5 minus 2 factorials equals 3 factorial equals 3 times 2 times 1 equals 6. Substituting the values. C 5 2 equals 120 over 2 times 6 equals 120 over 12 equals 10. There are 10 ways to select 2 students from 5. Conclusion: understanding permutations and combinations helps solve problems involving arrangements and selections. Practice with examples to strengthen your grasp of these concepts. Remember, practice makes perfect, so try solving more problems to strengthen your understanding. Bye-bye!